In science, we are taught that if you know the equations, you know the system, but across physics, biology, intelligence, and society, something strange keeps happening. The equations remain valid, and yet structure collapses, meaning disappears. Emergence fails, and this is not happening in one field. It happens everywhere, in completely different systems, with completely different equations, but with the same pattern. Radiation breaks at high frequency, biology fails outside oscillation windows, forces lose meaning at strong coupling, markets collapse under feedback, learning diverges, knowledge fragments, measurement fails, even explanation itself breaks. Different systems, different equations, same structural failure. We propose that every system has two layers. One describes how it evolves, the other determines whether that evolution remains stable, interpretable, and real. Emergence is not guaranteed, it is conditional. What follows are 12 cases across physics, life, intelligence, cognition, and meaning. Each one looks different on the surface, but underneath, they obey the same rule. Emergence appears only within a narrow region where stability and compatibility coexist, and disappears when that condition breaks. Zeroth case, theoretical dynamics. In the history of science, thinkers believed they understood explanation. Write the equations, derive the laws, predict the world. This is theoretical explanatory dynamics failure, direct analog, stability, and compatibility of explanations. Most theories don't fail because they're wrong. They fail because they're used where they shouldn't exist. This is the story of that mistake, a stable mistake, a compatible mistake. This is where the meaning emerges. Let me explain to you what I said. Theoretical explanatory dynamics describe how equations, models, and laws are applied to reality. Within stable and compatible operating ranges, predictions work and meaning holds. Below those ranges, explanations are incomplete but harmless. Beyond them, explanations become unstable or incompatible, producing paradoxes, infinities, and false certainty. Emergence by explanatory reach. At low explanatory reach, partial descriptions emerge. At intermediate explanatory reach, reliable theories emerge. At excessive explanatory reach, paradoxes emerge. Scientific failure is rarely caused by incorrect equations. It is caused by extending correct explanations beyond the dynamical conditions where they remain stable and interpretable. Meaning does not come from explanation alone. It emerges when explanations are constrained by stability and compatibility. This is not about replacing theories. It is about understanding where explanation itself becomes meaningful at all. First case. Radiation dynamics. In the 19th century, physicists thought they understood light. Their equations worked perfectly right up until they didn't. This is radiation dynamics failure, direct analog, UV dynamics. Classical radiation dynamics didn't fail because they were wrong. They failed because they were extended beyond the frequency ranges where energy exchange remains stable and compatible. This is the story of that mistake, a stable mistake, a compatible mistake. The quantization emerges. Let me explain to you what I said. Radiation dynamics describe how energy flows between matter and electromagnetic modes. With invisible frequencies, energy exchange is smooth, bounded, and mutually interpretable. Beyond that range, in the ultraviolet, the same equations predict infinite energy. Emergence by frequency at low frequencies implies classical radiation behavior emerges. At intermediate frequencies implies thermal equilibrium emerges. At high frequencies implies quantization emerges. Nothing breaks mathematically. What breaks is stability and compatibility with physical matter. Quantization emerges not as a new explanation of light, but as a stabilizing and interface-preserving structure that restores bounded energy flow. Second case, biological dynamics. In the late 20th century, biologists thought they understood fertilization. Sperm meets egg, DNA combines, development begins. This is biological dynamics failure, direct analog, Ca2 plus oscillation dynamics. Classical biochemical signaling dynamics didn't fail because they were wrong. They failed because they were extended beyond the calcium oscillation ranges where fertilization remains stable and decodable. This is the story of that mistake, a stable mistake, a compatible mistake. the life emerges. Explanation: biochemical signaling describes molecular reactions and pathways, but fertilization is not triggered by static chemistry. It depends on precisely timed calcium ion oscillations that remain compatible with cellular decoding machinery. If Ca2 plus dynamics are too weak, nothing happens. If too strong or uncoordinated, the egg cannot interpret the signal. Emergence by oscillation strength at low Ca2 plus oscillations implies no activation emerges at intermediate Ca2 plus oscillations, implies fertilization emerges at high or incoherent Ca2 plus oscillations, implies developmental failure emerges, life emerges only inside a narrow window of stable and compatible nonlinear ionic dynamics. Outside it, chemistry exists, but life does not. Third case, force/interaction dynamics. In the 20th century, physicists thought they understood forces. Fields interact, particles exchange, equations predict outcomes. This is force/interaction dynamics failure. Direct analog, coupling dynamics. Classical force dynamics didn't fail because they were wrong. They failed because they were extended beyond the coupling ranges where interactions remain stable and meaningful. This is the story of that mistake, a stable mistake, a compatible mistake. The forces emerge. Let me explain to you what I said. Force dynamics describe how fields and particles influence each other. At weak coupling, interactions are smooth, calculable, and mutually interpretable. Beyond that range, perturbation theory diverges, confinement appears, and particles cease to be compatible objects of description. Emergence by coupling strength. At low coupling implies free particles emerge. At intermediate coupling implies forces emerge. At high coupling implies confinement and breakdown emerge. Forces emerge not as fundamental things, but as stable, compatible interaction patterns that exist only within bounded coupling dynamics. Fourth case, economic dynamics. In the 20th century, economists thought they understood markets. Supply meets demand, prices adjust, equilibrium emerges. This is economic dynamics failure. Direct analog, feedback, and expectation dynamics. Classical economic dynamics didn't fail because they were wrong. They failed because they were extended beyond the feedback and expectation ranges, where markets remain stable and mutually interpretable. This is the story of that mistake, a stable mistake, a compatible mistake. The value emerges. Let me explain to you what I said. Economic dynamics describe feedback loops between prices, expectations, and behavior. In stable ranges, markets self-correct and signals remain interpretable. Beyond those ranges, during bubbles, crashes, or panic, the same equations amplify volatility and destroy shared meaning. Emergence by feedback strength at low feedback leads to stagnant value emerges. At intermediate feedback leads to market value emerges. At excessive feedback leads to bubbles and crashes emerge. Value emerges not as an intrinsic property but as a stable, compatible quantity that exists only when feedback loops remain bounded. Fifth case, knowledge dynamics. In the information age, researchers thought they understood knowledge. More data, more links, more insight. This is knowledge dynamics failure, direct analog. Semantic dynamics. Classical information dynamics didn't fail because they were wrong. They failed because they were extended beyond the connectivity ranges where meaning remains stable and interpretable. This is the story of that mistake, a stable mistake, a compatible mistake. The understanding emerges. Let me explain to you what I said. Information dynamics describe how facts propagate and connect. As connectivity increases, inference becomes possible. Beyond a critical point, connections overwhelm interpretation. Noise grows faster than insight. Emergence by connectivity. At low connectivity leads to isolated facts emerge. At intermediate connectivity leads to understanding emerges. At excessive connectivity leads to semantic collapse emerges. Understanding emerges only as a stable, compatible semantic configuration. When coherence is lost, meaning collapses, even though data remains. Sixth case, machine learning dynamics. In the early 21st century, engineers thought they understood learning. More data, larger models, better performance. This is machine learning dynamics failure, direct analog, training dynamics. Classical learning dynamics didn't fail because they were wrong. They failed because they were extended beyond the optimization ranges where models remain stable and aligned with interpretation. This is the story of that mistake: a stable mistake, a compatible mistake. The intelligence emerges. Let me explain to you what I said. Training dynamics govern how models update parameters. Through optimization within stable regions, learning generalizes and remains interpretable. Beyond them, models memorize, diverge, or hallucinate, losing compatibility with human meaning. Emergence by training scale. At low scale leads to underfitting emerges. At intermediate scale leads to general intelligence emerges. At excessive scale without control leads to hallucinations emerge. Intelligence emerges not from better rules, but from re-entering a new basin of stability and compatibility at higher dimensionality. Seventh case, cosmological dynamics. In the 20th century, cosmologists thought they understood the universe. Smooth space-time expands, matter evolves, structure forms. This is cosmological dynamics failure, direct analog, expansion, and structure dynamics. Classical cosmological dynamics didn't fail because they were wrong. They failed because they were extended beyond the density ranges where space-time remains stable and describable. This is the story of that mistake: a stable mistake, a compatible mistake. The universe emerges. Let me explain to you what I said. Cosmological dynamics describe how space-time expands and structures form. Within stable density ranges, galaxies emerge. Beyond them, singularities appear and predictability vanishes. Not because equations fail, but because description loses compatibility. Emergence by density at low density implies empty expansion emerges. At intermediate density implies cosmic structure emerges. At extreme density implies singularities emerge. The universe emerges only where expansion, gravity, and matter remain balanced. Eighth case, measurement dynamics. In the foundations of physics, observers thought they understood measurement. Systems evolve, observers record, outcomes appear. This is measurement dynamics failure, direct analog, observation dynamics. Classical measurement dynamics didn't fail because they were wrong. They failed because they were extended beyond the interaction ranges where observation remains stable and mutually interpretable. This is the story of that mistake: a stable mistake, a compatible mistake. The meaning emerges. Let me explain to you what I said. Measurement dynamics describe interactions between systems and observers. Without decoherence, outcomes do not settle. Meaning appears only when interactions stabilize and remain compatible with records. Emergence by interaction strength. At low interaction implies no information emerges. At intermediate interaction implies measurement outcomes emerge. At excessive interaction implies loss of distinction emerges, meaning emerges only when observation remains within stability and compatibility bounds. Ninth case, cognitive dynamics. In the study of mind, scientists thought they understood cognition. Neurons fire, signals propagate, thoughts emerge. This is cognitive dynamics failure, direct analog coherence dynamics. Classical cognitive dynamics didn't fail because they were wrong. They failed because they were extended beyond the coherence ranges where awareness remains stable and self-compatible. This is the story of that mistake: a stable mistake, a compatible mistake. The consciousness emerges. Let me explain to you what I said. Cognitive dynamics describe neural signaling and information flow. Within stable coherence ranges, awareness emerges. Below them, unconscious processing. Above them, seizures, fragmentation, loss of self. Emergence by coherence. At low coherence leads to unconscious processing emerges. At intermediate coherence leads to consciousness emerges. At excessive coherence leads to pathological states emerge. Consciousness emerges not from computation alone, but as a stable, compatible, dynamical coherence state of a nonlinear system. 10th case, chemical dynamics. In the study of matter, scientists thought chemistry was continuous. Atoms bond, molecules form, substances behave. This is chemical dynamics failure. Direct analog, phase, and bonding dynamics. Classical chemical dynamics didn't fail because they were wrong. They failed because they were extended beyond the temperature and pressure ranges where molecular interactions remain stable and compatible. This is the story of that mistake. A stable mistake, a compatible mistake. The phases emerge. Let me explain to you what I said. Chemical dynamics describe how atoms and molecules interact through bonding and energy exchange. Hydrogen and oxygen obey the same equations everywhere. Yet ice, liquid water, and vapor appear as entirely different realities. Emergence by energy at low energy implies ice emerges. At intermediate energy implies liquid water emerges. At high energy implies water vapor emerges. Nothing changes in the equations. Phases emerge when molecular motion becomes stable and compatible at specific energy ranges. 11th case, measurement dynamics. In science, observers thought measurement ended with observation. Measure once, record a value, publish the result. This is measurement dynamics failure, direct analog, record, and consensus dynamics. Classical measurement of measurement dynamics didn't fail because they were wrong. They failed because they were extended beyond the ranges where records remain stable and compatible across observers. This is the story of that mistake, a stable mistake, a compatible mistake. The facts emerge. Let me explain to you what I said. Facts are not single observations. They are stable, compatible records across time, instruments, and observers. When records drift or disagree, reality dissolves into noise. Emergence by record coupling. At low coupling, anecdotes emerge. At intermediate coupling, facts emerge. At excessive, uncontrolled coupling leads to misinformation emerging. Facts emerge only when measurement itself becomes a stable, compatible process. 12th case, cinema dynamics. In storytelling, creators thought they understood plot. Scenes happen, events follow, the story moves forward. This is cinema dynamics failure. Direct analog, narrative stability and compatibility. Classical narrative dynamics didn't fail because they were wrong. They failed because they were extended beyond the ranges where character journeys remain stable and emotionally compatible. This is the story of that mistake, a stable mistake, a compatible mistake. The story emerges. Let me explain to you what I said. Cinema dynamics describe how scenes, characters, and events unfold over time. A film can be technically perfect and still feel empty because meaning does not come from events alone. Emergence by narrative change at low transformation leads to boredom emerges. At intermediate transformation leads to meaning emerges. At excessive transformation leads to confusion emerges. Story emerges when transformation remains stable enough to follow and compatible enough to feel. A story is not a sequence of events, it is a dynamically stable arc of becoming. Across matter, physics, life, intelligence, measurement, story, and meaning, creation does not occur when equations succeed, but when stability and compatibility allow emergence. The equation of universal dynamics. This is not a new law of physics. It's a bookkeeping identity, a way to track how stability and compatibility are gained or lost. It tells us when behavior survives and when something new is able to emerge. Stability, compatibility, functional. Equations don't tell us whether a system makes sense. Stability alone doesn't either. Compatibility does. So instead of asking whether equations exist, we ask whether stability persists and remains interpretable. That is what this functional measures. High implies bounded, interpretable, emergent behavior, low to divergence, collapse, paradox, loss of meaning, stable and compatible units. Every domain has its own stable units. They are what survives and what remains interpretable. photons, radiation, oscillations, biology, particles, forces, prices, economics, concepts, knowledge, models, AI, outcomes, measurement, awareness, consciousness. Stable units are not fundamental objects. They are what remains coherent and compatible when dynamics stay inside viable bounds. Emergence is the moment these units become usable, and critical distinction, dynamic facts versus dynamic mysteries. Here's the mistake science keeps repeating. We treat breakdowns of stability and compatibility as mysteries instead of recognizing them as boundary crossings. Dynamic facts, what holds inside stable and compatible regimes where structure, meaning, and emergence persist. Dynamic mysteries implies what appears when stability or compatibility is violated, implies where emergence collapses into paradox. At low dynamical intensity, systems remain stable and compatible, facts emerge and persist. At intermediate dynamical intensity, systems remain interpretable, structure holds, meaning survives, and emergence continues. At high dynamical intensity, stability or compatibility breaks, emergence fails, and facts dissolve into paradox and mystery. The ultraviolet catastrophe was not a mystery, it was a stability and interface failure. Singularities are not mysteries, they are regime exits. Hallucinations are not intelligence, they are incompatibility under instability. Mystery is not depth. It is failed emergence caused by misapplied description beyond viable regimes, like a critical distinction. Dynamic living versus dynamic dying. There is another distinction we often miss, not between true and false, but between living dynamics and dying dynamics. Dynamic living leads to systems operating inside stable and compatible regimes, implies capable of recovery, adaptation, and emergence. Dynamic dying implies systems pushed beyond stability or compatibility, implies where emergence degrades into fragmentation, implies incapable of coordination, repair, or meaning. At low stress/low drive, dynamics are alive, structure is maintained, and emergence is robust. At intermediate stress, dynamics adapt, living systems reorganize, and emergence persists through change. At high stress, stability collapses, emergence fails, coordination breaks, and systems begin to die. Death is not the absence of equations. It is the loss of stable and compatible conditions required for emergence. Living systems are not defined by components. They are defined by the regimes in which emergence can survive. The paper, there is one more step. If stability and compatibility determine whether systems live or die, whether facts persist or dissolve, whether emergence succeeds or fails, then these ideas cannot remain informal. They must be written down. They must be expressed as structure. They must be given equations, not new laws, but a framework that tracks where dynamics remain viable. This is where the paper enters. The unified field theory of dynamics, not a theory of what exists, but a theory of when behavior remains meaningful. UFTD formalizes everything you've just seen. It describes how state-level dynamics evolve, how operating conditions drift, how stability is gained or lost, how compatibility is preserved or broken, and where emergence becomes possible or impossible. It does not replace physics, biology, or computation. It sits above them. As a map of viable regimes, what follows is not philosophy. It is a dynamical framework for understanding why emergence appears and why it disappears. The theory, once you see these two distinctions, facts versus mysteries, living versus dying, you realize they are not philosophical, they are dynamical. They describe where emergence is possible and where it is not. Once you see this pattern, you need new language. That language is regime theory, or more precisely, a theory of emergence. Regime theory, conditional stability, compatibility, and solvability in nonlinear systems. Regime, a regime is a region of parameter space where stability holds, compatibility persists, and emergence is possible. Regime boundaries, a regime boundary is where stability or compatibility breaks, not where equations fail. Regime limits. A regime limit marks the outer edge beyond which a description cannot remain coherent or interpretable. Equations may still exist there, but emergence does not. Regime law. A regime law describes behavior only inside a regime. It makes no claim beyond its limits. What emerges inside one regime cannot be demanded outside it. Regime transition. A regime transition occurs when a system crosses a stability-compatibility boundary and reorganizes. This is where emergence appears. Quantization, life intelligence structure awareness. Emergence is not addition. It is re-coordination. Regime exchange. A regime exchange happens when one description loses compatibility and another becomes stable and interpretable. Particles to fields chemistry to biology data to meaning no description is final. Only regimes persist. Regime swap. A regime swap occurs when two descriptions coexist and trade dominance. Wave to particle, classical, quantum, local. Global reality does not choose sides. It navigates compatibility. Regime observatory. A regime observatory is where regimes are observed. It is not a place, it is a stance. You don't ask what is true everywhere. You ask where does this remain stable, compatible, and meaningful? Regime life cycle. A regime does not simply exist, it lives. A regime has a birth, a regime has a maturation, and a regime has a decline. Regime emergence. A regime begins when stability and compatibility first align, when bounded behavior becomes reproducible. When new stable units become usable. This is the moment of quantization, life intelligence structure awareness. Birth is not sudden magic. It is the crossing of a stability-compatibility threshold. Regime expansion. As stability deepens and compatibility spreads, the regime grows. More subsystems coordinate. More interactions become interpretable. Emergence stabilizes into structure. At this stage, living dynamics are robust. Facts accumulate, meaning compounds. Regime saturation, but growth cannot continue indefinitely. At high constraint, stability increases but flexibility decreases. Compatibility may narrow as rigidity strengthens. The regime becomes efficient but less adaptive. Emergence continues, but novelty slows regime drift. When operating conditions shift, the regime begins to drift. Small instabilities appear. Compatibility weakens across interfaces. Boundaries become fragile. This is not collapse. It is erosion. Regime collapse. When stability or compatibility crosses a critical boundary, the regime dissolves. Stable units fragment. Descriptions lose coherence. Emergence fails. Collapse is not the failure of equations. It is the end of viable coordination. Regime renewal, but collapse is not the end of dynamics. A new regime can form if stability and compatibility realign. This is renewal. This is reorganization. This is evolutionary transition. A regime life cycle is not linear. It is cyclical. Birth to expansion, to saturation, to drift, to collapse, to renewal. Reality does not stay inside one regime. It moves through life cycles. The closing synthesis, the movie theater. Imagine you are sitting in a movie theater. The screen is constant. The projector is constant. The light is constant, but the films change, and with each film, a different world appears. Each film has its own characters, its own rules, its own physics, its own logic, its own meaning inside one film. Those rules make sense. Outside it, they do not. A comedy cannot be judged by the rules of a tragedy. A documentary cannot be evaluated as fantasy. A silent film cannot be criticized for lacking dialogue. The rules are not universal. They are regime-specific. A film begins. That is regime emergence. It develops structure. That is regime expansion. It reaches climax. That is regime saturation. It fades out. That is regime collapse. Another film begins. That is regime renewal. Sometimes the projection flickers. That is a boundary crossing. Sometimes two films overlap. That is a regime swap. Sometimes the genre shifts mid-story. That is a regime exchange. The theater itself does not change. What changes is which regime is projected. Reality is not one infinite film. It is a sequence of viable projections, each projection stable enough to hold together, compatible enough to be understood long enough for emergence to matter. When the projection is stable, a world appears. When compatibility holds, meaning survives. When both persist, emergence unfolds. And when stability breaks, the image tears, the sound distorts, the story collapses, not because cinema failed, but because the regime ended. Physics is a film. Biology is a film. Intelligence is a film. Consciousness is a film, each with its own stable script, each valid inside its own projection, none universal, all navigated. You do not ask, which movie explains the theater? You ask, which film is playing, and does it remain stable and compatible? And that is regime theory, not a theory of everything, a theory of when something holds long enough to become something, but a theory of emergence, a theory of when stability persists, when compatibility aligns, when boundaries are respected, when transitions reorganize, when collapse gives way to renewal, when structure survives long enough to matter, not explaining what exists everywhere, but revealing when existence becomes coherent, not replacing laws, but mapping where laws remain meaningful, not chasing infinity, but identifying the interior where emergence lives. That is regime theory. Final line, the universe is not one story, it is a theater of regimes, and emergence is what appears when the projection holds. Closing invitation. Anyone can test and reanalyze their own experiments using regime theory. It is not restricted to physics. It is not restricted to biology. It is a universal framework for identifying where stability, compatibility, and emergence coincide. You can explore the experiments I have reanalyzed using regime theory in the attached papers below. One analyzes the stability and compatibility structure of Behrend-Mons Fair principles, the percolation point of AI-based hypothesis testing in biology, and another reinterprets pharmacological data through stability-compatibility dynamics. If you are interested, I will also post a detailed video explaining those analyses step by step. Wait for minute. But if the universe is a theater of regimes, then the history of life is not a simple story of strength. It is a story of which projections hold. This forces us to redefine the very engine of evolution, moving from a struggle for power to a struggle for structural coherence. Survival of the fittest versus survival of the stable and compatible. We have long been taught the doctrine of survival of the fittest, a narrative of competition where the strongest or most adaptable individual wins, but regime theory proposes a deeper structural truth, survival of the stable and compatible. Fitness is fleeting if a system cannot resist internal divergence or external perturbation. True survival isn't about being the best, it is about remaining within the viable regime where stability prevents collapse, and compatibility preserves the system's meaning across scales. Dominance versus emergence. Dominance is an exercise of power within a state. Emergence is the birth of a new state entirely. While dominance seeks to control variables, emergence only occurs when the principle of emergent viability is met, when the product of stability and compatibility is greater than zero. Evolution is not merely a ladder of dominant species, but a sequence of emerging regimes that survived because they remained structurally coherent. The mysteries versus the emergence. We often ask the why of the universe. Why does morphogenesis stop at exactly 5 fingers? Why do quantum forces stabilize into exactly 3 generations of particles? Why does the electron possess the specific mass that it does? These are not mysteries of intent, but mysteries of the emergence functional, E equals S times C. Morphogenesis stops because the 5-finger state is the final point where stability, S, and compatibility, C, coexist. Matter is organized into 3 generations because they represent the only stable configurations allowed by the vector equilibrium of space-time. Even the mass of an electron is a result of this balance. It has the mass it does because that specific weight allows it to remain stable and compatible with the Higgs field. We do not ask who tells the particles how heavy to be. We recognize that their mass is the structural result of the equation of balance. Existence is the answer to the requirement of coherence. What was once mythic is now measured. What was once described as cosmic balance is now written as a functional. The universe is sustained not by a single equation but by the condition under which all equations remain meaningful. That condition is stability times compatibility. When positive, worlds appear. When broken, regimes collapse. Emergence is not mystical, it is conditional. The selfish gene versus the emergent gene. The selfish gene, the reductionist dogma. The selfish gene is a popularized view of the central dogma, which assumes that organisms are merely passive vehicles for DNA. In this model, information flows in only one direction, from the gene to the body. Evolution is viewed as a blind, bottom-up struggle for dominance, where genes compete to replicate themselves regardless of the stability of the whole organism. The emergent gene, the structural reality regime theory, proposes the emergent gene, a unit that exists not in isolation but as part of a self-excited circuit. Unlike a selfish gene, an emergent gene is a stable unit that survives only if it remains compatible with the collective dynamics of the cell and the organism. Scientific reframing. If a gene's impact deviates too far, it creates dynamical instability, the accumulation of structural variance that pushes the system toward a regime limit. At this boundary, the mathematical conditions for existence are no longer met and the system faces inevitable collapse. The self-excited circuit, the mechanism of agency. A self-excited circuit provides the structural mechanism for agency and persistence in living systems without requiring an external master controller. The breakdown of linear causation. Traditional biology assumes genes act as a master blueprint. However, research into the human heart reveals no single oscillator gene. Instead, the heartbeat emerges from the collective coordination of cells, a muscle that excites itself to be rhythmic through a network of interactions. Decentralized intelligence. The instruction for life is everywhere and nowhere. It resides in the emergent system, not just the code. The principle of emergent viability. The ultimate reason for a self-excited circuit is the principle of emergent viability. This principle states that existence is conditional. A system persists only as long as its operating parameters remain within a specific window or regime where the product of stability and compatibility is positive. Stability S. The system must possess a measurable resistance to collapse under perturbation, for example, Lyapunov exponents or entropy production rates. Compatibility C. The system must maintain basis relative coherence, ensuring that its internal dynamics remain interoperable across different scales. Regime transition. When a system crosses a boundary where S or C collapses, S to 0 or C to 0, a regime transition occurs. This provides the scientific answer to morphogenesis. The stop point for 5 fingers is simply the limit of the emergent viability of that growth regime, the agency of the whole. The emergent gene is governed by biological relativity. The genome does not act as a master blueprint. Instead, the living cell and the body as a whole control the genome. Two-way causation. Information flows both ways. The body tells the genome what to do to maintain stability. The error correction rule. The cell will not allow itself to divide until the genome is accurately replicated, proving that the intelligence of life resides in the emergent circuit. We move from the image of the gene as a master to the gene as an organ of the cell. We no longer rely on a master blueprint or mystical instruction. Instead, we recognize that reality is a sequence of stable projections. Survival is not about being the fittest competitor, but the most stable and compatible participant in the regime of life. Life persists not by intervention, but through the rigorous mathematical requirement of emergent viability. The Big Bang versus the emergent space-time. We often look back to the Big Bang and ask, what caused the ultimate beginning? Standard cosmology points to a mathematical singularity, a point of infinite density where general relativity completely breaks down. But this is not a mystery of creation, it is a crossing of regime limits. The early universe did not emerge from a mystical nothingness. As cosmological density scaled toward the extreme, the system crossed a critical threshold where stability S dropped to 0. When stability collapsed, the physical equations didn't stop existing, they simply lost their compatibility, C, with classical space-time boundaries. The Big Bang was not the birth of physics, but a massive regime transition, the exact moment where the cosmic film stabilized. The product of the emergence functional, E equals S times C, became positive, and a structured interpretable universe appeared. The expansion we observe today is the ongoing evolution of a stable projection. We do not ask what happened before the Big Bang. We recognize that the cosmic singularity was merely the edge of the previous regime. The image on the screen only remains clear as long as the projector follows a precise set of constraints. When we apply this logic to reality, we find that the laws of order and balance are not just ancient metaphors, they are the fundamental parameters of a universal dynamic. God's theory, God's equation. If we define God not as a personified deity, but as the universal structural condition that sustains order, we arrive at God's equation. This is the invariant law of the universe. It asserts that worlds appear not by random chance, but only when resistance to collapse, stability, and interpretability, compatibility, align. This equation represents the divine dynamics that allow reality to remain meaningful. The karma equation, structural karma, is the dynamical consequence of boundary crossing. We can express the karma equation through the stability functional. In this framework, bad karma is the accumulation of dynamical variance that pushes a system toward a regime limit. When the balance is transgressed, the system inevitably faces collapse. Karma is not a moral judgment, it is the mathematical inevitability of a system losing its stability and falling into chaos. If emergence is what appears when the projection holds, then we must ask, what defines the boundaries of the lens? What determines whether a system thrives or fragments? The answer lies in a structural reformulation of how we understand existence itself. Regime theory is the study of conditional persistence. It teaches us that the laws of physics, biology, and society are not absolute, they are context-sensitive. Equations define what is possible, but regimes determine what lasts. A regime is a sanctuary in parameter space where law and reality coincide. Beyond its boundaries, the equations may still exist, but the world they described disappears. The theory of emergence is the final synthesis. The understanding that more is different. Complexity arises only when internal metabolic or mechanical regulation, stability, meets genetic or semantic interoperability, compatibility. From the coherence of a single neuron to the shared norms of a civilization, emergence is the prize of balance. It is not mystical, it is a measurable, universal, and conditional state of being. What was once mythic is now measured. What was once described as cosmic balance is now written as a functional. The universe is sustained not by a single equation, but by the condition under which all equations remain meaningful. For centuries, science believed that if we knew the equations, we knew the system. We chased the ultimate laws, believing that truth was a destination written in stone. But across physics, biology, and consciousness, nature hides a deeper riddle. Equations remain flawless, and yet meaning vanishes. Structures break. We point our telescopes at the cosmos and ask, why does the Higgs field grant the electron its exact, precise mass? Why is the universe organized into exactly 3 generations of fundamental matter? We turn our lenses inward to the mystery of life. Michael Levin looks at the currents of morphogenesis and asks, who tells the cells to stop building at exactly 5 fingers? Where is the shape held? Denis Noble challenges the old dogmas. If the genome is just a list of ingredients, how does the living cell know how to read it? How does the whole organ guide the code to survive? And at the boundary of reality itself, Roger Penrose Penrose maps the ultimate trinity, the physical, the mental, and the mathematical, a paradox of existence, a profound architecture we are only beginning to decode. These are not anomalies of intent. These are not separate mysteries. From the fine structure constant of Dirac and Pauli to the self-exited circuits of life, they are all whispering the exact same structural truth. We have spent lifetimes asking what is true everywhere, but the true theory of everything is not a single rigid formula. It is a map of where our descriptions remain stable, compatible, and real. The universe is not one infinite story. It is a theater of regimes, and reality is what appears when the projection holds.